Hey guys, Mr. Girk here. Just gonna give you a quick tutorial on finding the greatest common factor between two monomials. So let's check to make sure this test is working. So we're good. All right, so find the GCF of these two monomials. We've got 3x cubed and 12x squared. So when it says find the GCF, that's the greatest common factor. Okay, so we got to talk about what are common factors. So if you remember, common factor are things that you can divide a number by. So let's just talk about the coefficients first of these. Oops, let me get my pencil. Bear with me. I am learning how to do this. All right, so let's talk about the coefficients. All right, so 3 and 12. So the greatest common factor, what's the biggest number that I can divide the 3 by and the 12 by? Biggest number you can divide the 3 by and the 12 by. So what that means is, so if I come over here and I do 3, what are the numbers I can divide 3 by? Well, I can do 3 divided by 3. I can do 3 divided by 1. All right, what about 12 though? What are some numbers I can divide 12 by? I can do 12 divided by 6, 12 divided by 4, 12 divided by 3, 12 divided by 2, and 12, where's it at? Come on now. Let's see if that worked. And 12 divided by 1. So those are the numbers that we can divide 12 by. Those are the numbers we can divide 3 by. We're looking for the greatest number of all those. So the biggest number right here for our, come on now. Greatest number for our 3 is 3. Biggest number for our 12 is 6. But we need the greatest common. So C is common. So which one do they have in common? That's the biggest. The biggest number they have in common is a 3. They also have a 1 in common with each other, but we're looking for the greatest common. So that's going to leave us with the 3 and the 3. So the first step to our GCF is finding the greatest common factor of our coefficients. So 3. Now we need to find the GCF of our variables. Here's how you do that one. So I just kind of like to break them apart. So how do you write x cubed? Well, it's the same thing as x times x times x. There's 3 x's, x times x times x, x to the third. What about x to the second? X to the second is x times x. Now let's pair them up. All right, so what I mean by pair them up is how many pairs of x's do I have? From top and bottom, okay, they share one pair. And they share another pair. This guy's all by himself, right? He does not have a pair here. There's no x here. All right, so we only have one pair. We've got 2 pairs. So that means that our GCF, or our greatest common factor of our variables, is x to the second. So they have 2 pairs. 1, 2. So that means our variable is 2. So we take our GCF of our coefficient. We take our GCF of our variable and we put them together. And that's our GCF. That's our answer. So if it said find the GCF of 3x to the third, this one is picky. Okay. 3x to the third, GCF of 3x to the third and 12x to the second. The GCF is 3x to the second. All right, let's try another one real quick. See if this one clears some confusion if there is any. Okay, so we need to find the GCF of 10x cubed and 15x. All right, so we do the coefficients first. Okay, GCF of 10 and 15. All right, I can do 10. I can divide 10 by 5. I can divide 10 by 2. I can divide 10 by 1. Actually, you know what I'm forgetting? I'm actually forgetting the numbers themselves. I could also do 10 divided by 10. Sorry. So if we go back to these previous ones, I should have had. I did 3 divided by 3. I should have done. Oops. There we go. Stop. I also should have done 12 divided by 12. Sorry, that wouldn't have changed our answer, but I should have had that in there. All right, coming back. Sorry. All right, so I can divide 10, by 5, by 2, and by 1. What can I divide 15 by? Let me separate that. All right, I can do 15 divided by 15, 15 divided by 5, and 15 divided by 3, and 15 divided by 1. That leaves us with, what do we have in common? So what we have in common is 10, no, 5, yes, 2, no, 3, no, and the 1. So which one's the greatest? What's the biggest one? The 5. So our GCF of these two coefficients is 5. Now we need to find the GCF of our exponents, x to the third and x. So let's rewrite x to the third as x times x times x. And x, there's nothing there. There's no exponent, so we're just going to write 1x, one of the x's, because if it was x to the second, we would have write 2 x's, x to the third, we would have wrote 3 x's. It's just x, so we're only going to write 1x. Now, how many pairs can we match it? Do they have in common? Can we match them up? Just one pair right there. That's it. Okay. This one, there's no x here. This one, no x here. So there's only one pair. So our GCF of these two, of this and this, our GCF is x. We're going to take this x, we're going to put it over here with our GCF of our coefficient, and that is our GCF of these two monomials, 10x cubed and 15x. The GCF is 5x. Let's see what we got here. We're going to use our GCF now to factor. You will not see any problems like this in your assignment on big ideas, but you will need to know how to find the GCF of monomials in order to factor. So this is the first factor problem that you guys are going to see. All right. So factoring, that's just the fancy way for undoing. So we're just going to undo a lot of math here now. Okay. So the first factoring that we're going to do is factoring using the GCF, or factor using the greatest common factor. All right. So right now I've got a binomial with two terms. I've got 12x to the third plus 3x squared. What we're going to use to factor this is the greatest common factor. So in order to do that, we're going to do the exact same stuff that we were doing over here. Okay. We have to find the GCF of the two terms over here, the 10x cubed and the 15x. We're going to do the same process. I've got two terms, two monomials, just like we had in the last two, but there's a plus there. So what we're doing is we're actually undoing the distributive property. Okay, so we're going to factor or undo this one using the distributive property. So the first thing we need to do is figure out what is the GCF of these two. So let's do what we've been doing. All right, what is the GCF of our two monomials? So let's look at our coefficients first. So what's the GCF of 12 and 3? So what could I divide the 12 by, and what could I divide the 3 by? Well, the greatest common factor between the two of them is, if you want to take the time to do the division and write that out over here, like we did over here, all right, you're more than welcome to. But if you know it off the top of your head, it should be 3. So our GCF is, between these two, is 3. All right. Now, the GCF of our, wrong color, GCF of our exponents is, one more time, x to the third is the same as x times x times x. X to the second is x times x. That leaves us with two pairs and x to the second. Here's a little trick if you haven't figured it out yet. Are you ready? When you're looking for the GCF of two, exponents, or two variables with exponents, it's always going to be the one that has the smaller exponent. So for example, x to the third and x squared. What's the smaller exponent? The 2. That's our GCF for that one. Let's come over here. This one was x to the third and x. Which one's smaller? The x is. All right. The x is smaller. Hold on. Come on. There we go. This x is smaller, so that means that's our GCF. Okay, if we come over here to our first one we did, we had x to the third again, just like our previous one, and x to the second smaller, and that turned out to be our GCF. So there's a little trick. Whatever one's smaller, that's your GCF. So let me erase some of this stuff here. We've got our GCF is 3x to the second. So what we're going to do is, like I said, we're going to undo the distributive property. So the distributive property, remember, we need parentheses. So let's put some parentheses in there. Okay. Our GCF is always going to go right there. All right. So let me move this. Oops. Undo. Is there an undo? I don't see one. I'm sure it's somewhere. I'll just erase it real quick. Oh, there it is. Undo. See if I can do that. Nope. Undo. Whatever. So our GCF in this problem is 3x squared. So we're going to write our GCF right here. All right, 3x squared. What we need to figure out is, or since we're undoing the distributive property, okay, what do we need to go in here inside of our parentheses? Well, definitely need our plus sign. Now, what do I need to multiply, since the distributive property is multiplying your outside term by everything inside the parentheses, since we're undoing 12x, let me do this real quick, since we're undoing 12x to the third plus 3x squared, if I'm going to undo it, how would I get back to it? So that means 3x squared times what is 12x to the third? Well, let's do this. 3 times what equals 12? 4. Okay. Now, x squared times what equals x to the third? That's an x. So 3 times 4 is 12. X squared times x is 12x. Or excuse me, x squared times x is 12x. Or excuse me, x squared times x is x to the third. 3 times 4 is 12x. Here's 12. And x times x squared is x to the third. So 3x squared times 4x gives us x to the third. Now we need to figure out, what do I multiply 3x squared by to put here to get to 3x squared? Well, they're the same term. We've got 3x squared. I got 3x squared. So what do you multiply something by to keep it the same? The answer is a 1. So this gives us our answer. We factored out our GCF. We put it out in front. So our answer is 3x squared times 4x plus 1. And that's our answer for factoring out the GCF. We're going to do a couple more if that one was really confusing.